In 1856, Eunice Newton Foote placed a glass cylinder full of carbon dioxide and one filled with ordinary air in the sunlight. She found that the one filled with carbon dioxide heated up more than the one filled with ordinary air. Her conclusion? More carbon dioxide in the atmosphere results in a warmer planet. Since then, studies have reaffirmed that greenhouse gases such as carbon dioxide contribute to the greenhouse effect and global warming. From simple physics experiments like Foote's to vast climate records spanning millennia, scientific data is key to understanding climate change. In this video, we'll explore greenhouse gases, the impacts of global warming, and how data science can address climate change. In the vast expanse of space, Earth stands out as an oasis of life, all thanks to a thin layer enveloping it, our atmosphere. This band of air is unique to Earth, and we wouldn't exist without it. The atmosphere is made of multiple gases, mostly nitrogen and oxygen. But some are special, like carbon dioxide, water vapor, nitrous oxide, and methane. These are called greenhouse gases because they trap heat like a greenhouse for growing plants. Unlike nitrogen and oxygen, greenhouse gases are made up of 3 or more atoms. These molecules have bonds that can absorb and emit infrared radiation, which is a type of heat energy. This unique structure allows greenhouse gases to trap heat in Earth's atmosphere. They only make up 1% of our atmosphere, but without them, our planet would be a frozen wasteland. Here's how they work. The sun sends us solar radiation. When this radiation reaches Earth, some of it is absorbed, and the rest bounces back as infrared radiation. Some infrared radiation manages to escape into space, but a portion is captured by gases like carbon dioxide. The gases re-emit the radiation in various directions, including back to Earth's surface. That's the greenhouse effect in a nutshell. Human activities such as power generation, agriculture, and transportation are increasing the amount of greenhouse gases in the atmosphere. This is enhancing the greenhouse effect and raising Earth's average temperature, causing global warming. Not all greenhouse gases affect Earth equally. Their impact depends on 3 factors. 1, their concentration in the atmosphere. 2, how much energy they absorb. And 3, how long they stay in the atmosphere. Some, like water vapor, don't stay in the atmosphere long enough to cause much trouble. Others, like carbon dioxide, can linger for up to 1,000 years, making them major players in climate change. So even the carbon dioxide emitted from fighter planes way back during World War I is still in the atmosphere, heating things up. To compare the effects of different greenhouse gases, we use a metric called global warming potential, or GWP. It measures how much heat a certain amount of gas traps over a set time compared to carbon dioxide. Carbon dioxide has a global warming potential of 1, while methane has a global warming potential of 28. This means that in the first 100 years of its emission, 1 kilogram of methane contributes 28 times more to the greenhouse effect than 1 kilogram of carbon dioxide. The impact of nitrous oxide is 273 times greater than carbon dioxide. Chlorofluorocarbons, or CFCs, which are used for aerosols, solvents, and refrigerants, have the highest global warming potential, sometimes reaching into the thousands or tens of thousands. Global warming has significant consequences for the environment and for people. Rising temperatures cause more frequent and severe heat waves, droughts, floods, stronger storms, and rising sea levels which threaten coastal communities. And these disruptions have cascading effects, harming biodiversity, food security, and human health. While Earth has survived past climate shifts and mass extinctions, human civilization only appeared about 10,000 years ago during a period of climate stability. We weren't around for past climate shifts and certainly wouldn't survive one now, Earth, however, will endure regardless. So the urgency of fighting climate change is not to save Earth, but to safeguard our future. To understand global warming and its impacts, data science is essential. It's a multidisciplinary field that helps to communicate and identify patterns in data. Consider a remark about a colder than usual winter. This is an anecdote, not conclusive evidence. Data science analyzes vast amounts of climate data, such as temperature records, precipitation patterns, and ice core samples, moving beyond single events to reveal broader trends. This helps us make informed decisions when addressing climate change. Facing the challenges of a warming world, we must use data science to guide our choices and ensure a sustainable future for generations to come.